Here's pre-calc. It's part 2 of your lecture for 5.2.1. So problem 5-39 says another useful logarithm is the natural logarithm, or the logarithm with a base e. It is expressed as log base e of x, but more often ln x, which is like natural log of x. When speaking, the two letters are stated separately as ln x. ln x. Okay, so it's got a base of e. It's got a tiny little e. And e is just that number that you learned about that's 2.71. You can think of it as being kind of close to 3-ish. Without a calculator, evaluate each of these expressions involving the natural log. So just imagine there's a little e. These little invisible e's, those are the bases, okay? So I'm going to do it on paper so you can see it better. So ln e, or ln naturally has a base of e. So I'm just going to do this like I would do any other problem. I'm going to ask myself, e raised to what power would equal 1? E raised to what? E raised to the what equals 1. So, and you can just write that as e to the something equals 1, or you could say e to the x equals 1. Well, anything raised to the 0 power equals 1, and that's why I wrote my answer as 0. And this one I would say e raised to the what equals e. Sorry, because we don't have this part yet. That's the part that we don't know. So e raised to the what equals e, and then my answer was e raised to the first power equals e. This one's e raised to the what equals root e. Okay, well, e raised to the 1/2. Whenever you raise something to the 1/2, that gives you a square root. This one has those matching, like it has e to the ln x, but ln x has a base of e, so the bases match, so the answer is x. And 5-40, log base b of n equals m. So if I want, so what I think of when I think of this is b raised to the what power equals n, but they already told me the answer is m. So really it's b raised to the m power equals n. So b raised to the m equals n. Now they're asking us, it's 5-40, and in the question they said, can a logarithm have any, can it have any base? Can you take the logarithm of any number? With your team, investigate the possible values of n, m, and b in the equation below. That's the equation I have written on my paper. Record your conclusions and be prepared to share your findings with the class. So I'm just going to go through each of the variables and ask myself, can they be any value? Like we'll start with b, and then we'll do n, and then we'll do m. So can b be any value? Can it equal any value? So like if I have this, can I let my b be a negative number? Would that be okay? Can it be a 0? So I like to rewrite it into exponential form. B raised to the m equals n. And that helps me to decide what values b can be. So I know one thing. I know that if b is a 1, if b equals 1, then no matter what power I raise it to, the answer is always going to be 1. And so we don't allow, we kind of restrict the domain. We don't put in, like, I wonder what my calculator would do if I told it log, oh wait, never mind. This calculator doesn't, I can't do it that way. Anyway, I don't know what a calculator would do if you said log base 1. So b can't be 1. It can't be a negative number, because if I have b as a negative number and then I raise it to, I don't know, like if b was like -3 or something, then when I raise it to an even integer, if I raise it to an even power, I'm going to get a positive value. But if I raise it to an odd exponent, I will get a negative value. And my graph of logarithm graphs, they always look like this usually. But this one, if I allow b to be negative numbers, then it's going to jump around like depending on whether I'm raising it to even or an odd exponent. It's going to change from positive, negative, positive, negative. So we don't allow b to be a negative number, and we don't allow b to be 0, because anything to the 0 is 1. So that doesn't really, or sorry, because 0 to the anything, I showed a movie in my integrated 3 class about that. When you raise 0 to powers, it sometimes doesn't really make sense. So b can only be, well, it can't be 1 or negative or 0. So it has to be, I guess, it's kind of weird. It can be between 0 and 1, like it can be a fraction. Or it can be greater than 1. Like it has to be a positive number. It basically has to be a positive number that's not 1. That's the deal with b. And then n. So can n have any value? I'm thinking n can't be negative, because is there some number that I can raise to a power and get a negative answer? Think, and you will find that there's no number that you're going to be able to think of that you can raise to any power to get a negative answer. Okay, even if you raise, well, I mean, b can't be negative, but even if you did raise a negative number to a power, or a number to a negative power, you're not going to get a negative answer. So n can't be 0, because when you raise something to a power, you're not going to end up with 0, and it can't be negative. And then m, can m be any value? It can. So in other words, I can take my positive b and I can raise it to any power I want. So m can be any number. So that's just, I don't know, maybe I took too long on that. That was 5-40. And here's 5-41 we're going to solve. So it says ln of 3/2 x plus 9 equals 1. So the way you solve these things is, remember that if it's ln, it has a base of e. And then put that in exponential form. So you say e raised to what equals this. And well, you have the answer there. So you're going to say e raised to the first power equals this argument. So that's what I did as my first step. And then I know e is just a number. It's like 2.71 something. It's like kind of close to 3. So I'm just going to, if I raise it to the first power, it's still just e. So I just subtracted 9 on both sides. And I want x by itself, so I multiplied both sides by the reciprocal of 3/2, which was 2/3. Because if I multiply this by 2/3, I'll get 1. So, and I multiplied this side by 2/3. And then I distributed, and I got that. And then if I want, so this has an invisible base of 10. And then if I want to So this, if I rewrote it, it would be 10 to the what equals negative 3. Well, 10 to the something equals negative 3. Well, that's not possible. There's no number I could raise 10 to that would give me a negative answer. So I just say impossible, no solution. And that's it.